Hello all, in my previous class I discussed breakdown in a transistor and configuration of the BJT. One of the configuration of the BJT, that is common base configuration. Now in this class I will start with the common emitter configuration. Right. See, in common emitter configuration, which one is common here? Emitter is common, right? Now here I am drawing the symbol in common emitter configuration actually. Emitter is common means I think it is connected to ground, right? Input is given to base, right? And output is taken from collector. Here what are the input current? IB, and input voltage is nothing but VBE, and output current is nothing but IC, and output voltage is nothing but VC. Right. This is the common emitter configuration. BJT in common emitter configuration. Right. Now we will check. We will see the response of input and output characteristics actually. Right. So the first I start with input characteristics. Input characteristics. Now see here, these input characteristics are drawn between IB versus VB by keeping which one is constant actually? VC is constant. VC is constant actually, right? See here, what is IB here? IB is nothing but current through this emitter junction. What is this IB? IB is nothing but current through this emitter junction actually. This VB is nothing but what actually? Voltage across the emitter junction. That means the input characteristics are resembles the junction characteristics. The input characteristics are resembles the junction characteristics, right? And one more point actually, see here. See, if VB less than or equal to VB cut-in voltage, VB cut-in, then what will be the base current actually? The base current equal to 0, right? If VB is greater than cut-in voltage, if the VB is greater than cut-in voltage actually, VB cut-in, then what happened to IB? IB is suddenly increases. See here, if VB is less than the cut-in voltage actually, this is the cut-in voltage, okay, then what should be the IB actually? 0, right? If the VB is greater than the cut-in voltage actually, see here, IB suddenly increases. IB suddenly increases, right? This is VC1 and this is VC2, right? Okay, this is the input characteristics. See, and one more point actually, see, for a given value of VB, this IB is inversely varies with VC, right? How it is inversely varies actually? Why it is inversely varies? Due to early effect actually. And how it is inversely varies with VC? See all of you, due to early effect, I know, due to early effect, right? So here, what is early effect? See, if the VCB is increases, what happened to the VCE? VC also increases. How the VC is increases? What is VC actually? VC is nothing but VCB minus VB, right? If the VCB is increased means I think VC is increased actually. If the VC is increased, right? What happened to effective base width actually? Effective base width is decreases. If effective base width is decreases means what happened to number of recombinations? Number of recombinations within a base region, number of recombinations within a base is decreases. If number of recombinations within a base decreases means what should be the IB actually? Decreases. Now see here, how IB and VC are actually inversely related actually, right? Inversely related. And one more point actually, see if the VC is increases actually, the input characteristics are move towards right side. Means towards right side means in this way. If the VC is increases, it will move towards right side actually, right? This is about input characteristics of common emitter configuration, right? Yeah, write on the notes. Write on the notes. It is a plot of next. It is a plot of IB versus VB. IB versus VB by keeping VC is constant. By keeping VC is constant. By keeping VC is constant. Next point. IB is the current through the emitter junction. IB is the current through the emitter junction. VB is the voltage across the emitter junction. Voltage across the emitter junction. Therefore, the input characteristics are resembles the junction characteristics. Input characteristics are resembles the junction characteristics. Junction characteristics. Right. Next point. If VB is less than or equal to VB cut in, if the VB is less than or equal to VB cut in, in bracket cut in, then IB is 0. IB is 0. Right. IB is 0. Next one. If the VB is greater than VB cutting, VB is greater than VB cutting, then IB is increases suddenly. IB is suddenly increases. IB is suddenly increases. Right. Next point. For a given VB, IB is inversely varies with VC. IB is inversely varies with VC due to early effect. Right. Yeah. Copy this flow graph. How it is inversely increases. This total one. Yeah, copied. Next, output characteristics. Next one, output characteristics. Right. So now all of you, output characteristics are drawn between IC versus VC by keeping which one is constant? IB is constant. IC versus VC, IB is constant, right? The characteristics are like junction characteristics. Already we discussed in common base output characteristics, same as like, right? But the difference is, in case of common emitter, these output characteristics are extended towards backward, due to early effect up to a point of minus VA comma 0, where VA is the early voltage. VA is the early voltage. This early voltage in order of 50 volts to 100 volts. This is IB1 and IB2 and IB3. Right. Yeah. Copy this one. Yeah, copied now. Write down. The output characteristics are drawn between IC versus VC. IC versus VC by keeping IB is constant. Right. Next point. In common emitter, the output characteristics are extended towards backward up to a point of minus VA comma 0 due to early effect. Extended towards backward up to a point of minus VA comma 0 due to early effect, where VA is the early voltage in bracket. It is an order of 50 volts to 100 volts. 50 volts to 100 volts. Right. Next, so now all of you see, based on these output characteristics, okay, the BJT can operate in 3 regions actually. One is cutoff region, and the next one is saturation region, and third one active region. Right. Okay. So first I start with cutoff region. See, what is cutoff region actually? Cutoff region is nothing but the region in which okay, IB is 0, the region in which IB is 0, and also right of the VC. Right of the VC means, I think, which portion? This portion, right? Right of the VC means this portion. This region is called as which region? Cutoff region, right? See, in case of in this region actually, if IB equal to 0, right? If IB equal to 0 means I think no current is passing through this junction, right? If no current is passing means I think this junction is in which bias actually? Reverse bias, right? Similarly, VC is right of the VC, right? VC is greater than or equal to VC of SAT. VC of SAT means this is the saturated voltage actually. I think this point, this is the saturated voltage. If the VC is greater than VC of SAT, if the VC is greater than VC of SAT actually, then what should be the collector junction actually? The collector junction is in reverse bias, right? If both will be reverse bias means, if the both will be reverse bias means the BJT is in which region actually? Cutoff region, right? Yeah, write down. Write down. Based on output characteristics, based on output characteristics, BJT is operated in three regions. BJT is operated in three regions. The first one, cutoff region. The first one, cutoff region, and the second one, saturation region, and second one, saturation region, and third one, active region. Third one, active region. Yeah, next heading, cutoff region. Next heading, cutoff region. Write down the region in which IB is 0, IB is 0 and right of VCE and right of VCE. Right. Write down the conditions. IB is 0, then emitter junction is reverse bias. If VC is greater than VC of SAT, then collector junction is reverse bias. It is in such cutoff region. Yeah. Next one, saturation region. Saturation region. See, what is saturation region actually? Saturation region is nothing but the region in which IB greater than 0, right? IB above 0 or greater than 0 and left of the VC. Left of the VC means I think this portion actually. Left of the VC means this portion. This is which region? Saturation region actually, right? See, if IB is greater than 0, if IB greater than 0, then what happened to emitter junction? Actually, emitter junction is in which bias? Forward bias. IB greater than 0 means I think it will lose some current, right? That means that junction is in forward bias. Similarly, the VC is less than VC of SAT. Less than VC of SAT, right? Left of the VC, right? Left of the VC means I think what about the collector junction actually? The collector junction also forward bias. See, greater than means reverse bias, less than means forward bias. If both junctions are forward bias means I think it is in which region? Saturation region, right? Following or not? And one more point actually, in case of saturation region, this collector current will depends on what actually? This collector current will depends on both IB as well as VCE. It varies with both IB as well as VCE, right? Yeah, right on. Saturation region, next one. The next one, saturation region. Write down the region in which IB is greater than 0, IB is greater than 0 and left of the VCE, left part of the VCE, left part of the VCE, right? Write on the conditions. Right. Next, write down point. In saturation region, the collector current depends on, in saturation region, the collector current depends on both IC. In saturation region, the collector current depends on both IC and the collector current depends on IB and VC, right? This is about saturation. And the last one, active. Active region, right? See, what is the active region actually? Active region is nothing but CLFU, the region in which IB is greater than 0, right? IB greater than 0 or IB above the IB equal to 0. That means this portion and right part of the VC. Right part of the VC means I think this portion. This region is called as what actually? Active region actually, right? See here, all of you see here, see if IB is greater than 0. IB greater than 0 means, I think what is the emitter junction actually? The emitter junction is operated in forward bias, right? Similarly, VCE is greater than VCE of SAT. If the VCE is greater than VCE of SAT, okay, what about the collector junction actually? Reverse bias, right? See here, emitter junction is in forward and the collector junction is reverse means I think it is in which region actually? Saturation region actually. Sorry, active region. It is in active region. And one more point actually, in case of active region, this collector current will depends on what actually? This collector current will depends on IB and independent of VCE. IB independent of what actually? VCE, because we know in common emitter configuration IB equal to beta times of IB plus 1 plus beta into IC naught. See here, in this actually the collector current depends on what actually? Base current, independent of what actually? VCE, right? Yeah, copy. Write down. Next heading, active region. Next heading, active region. Write down. The region in which IB is greater than 0, and VC greater than, right part of VC, or VC greater than VC of SAT. You can write VC greater than VC of SAT also, not a problem. Right part of the VC of SAT. Right part of the VC. Right part of the VC. Right? Yeah. Copy the two conditions. Copied? Yeah. Write down. In active region, the collector current depends on, in active region, the collector current depends on IB. The collector current depends on IB and independent on VC. The collector current depends on IB and independent on VC because write down this equation, IC equal to beta times of IB plus 1 plus beta into IC naught. Right? This is about active region actually. Actually, here, in case of common emitter configuration, the output characteristics are extended toward backward up to what point actually? Early voltage, right? You know this early voltage is used to calculate calculation of IC when VC changed, and also calculation of the output resistance, right? Yeah, write down this point actually. Write down this point. Early voltage is used. Next point. Early voltage is used to calculation of first one. IC when VC changed. IC when VC changed. Second one, output resistance. The second one, output resistance. Yeah. The first heading, calculation of IC when VC changed. Calculation of IC when VC is changed. Right. See here, to calculate this one actually, calculation of IC when VC changed actually. See here, I am considering a point. So here this point is considered as A, and I think here I can consider a point at B. And what is this B point actually? This B point is nothing but VC1 comma IC1, and one more point I can consider, that is C, that is VC2 comma IC2. Right, I am considering 3 points for calculation of IC when VC changed. Right, now I am calculating the slope between A and B. Okay, slope due to points A and B. What is the slope actually? Slope is nothing but, I think you know, y2 minus y1 by, when 2 points are given, how to calculate the slope actually? Y2 minus y1 by x2 minus x1, right? Here what is the y2 here? Actually y2 is nothing but IC1 minus 0 by VC1 minus of minus plus VA. So which is equal to IC1 by VC1 plus VA. Right? Next, calculate the slope of B and C. Right? What is the calculation of the slope of B and C actually? IC2 minus IC1 by VC2 minus VC1. See, IC2 minus IC1 by VC2 minus VC1 is nothing but we can written as delta VC. Right? Now, see all of you. Here I think this all points are in, means this A, B, C and points are in the same line. Right? When 3 points are in the same line, their slopes must be equal. Here I am writing, right? A, comma, B, comma, C points are in same line, so that slopes must be same. Right? Here this is IC1 by VC1 plus VA. Next, IC2 minus IC1 by delta VC. Right. Now, here delta VC into, I am rearranging this equation actually, delta VC1 into IC1 by VC1 plus VA equal to IC2 minus IC1, right? Here, this early voltage in order of what actually 50 to 100 volts, right? So compared to this value, actually compared to this value is very small actually. VC is very small compared to VA because this is an order of 50 to 100 volts, right? So it can be written as, neglect this one actually. Neglect this one. Then delta VC into IC1 by VA equal to IC2 minus IC1, right? Now what is the final expression actually? IC2 equal to IC1 into 1 plus delta VC by VA. This is the calculation of collector current when VC changed. Yeah. Copy. Here, write only the consider. Written a question. Written a question in classroom workbook. Question number 4. In classroom workbook, question number 4. Written a question. A transistor has early voltage of 75 volts. Early voltage of 75 volts. And it is operating at a collector current of 1 milliampere. And it is operating at a collector current of 1 milliampere. When VC equal to 1 volt, Next one, if VC is increases to 11 volts, then IC is right. Now first of all, what is given data actually? They given a Early voltage. How much? 75 volts. I'll have to read the question. Early voltage is 75 volts, right? And what is the collector current actually? The collector current equal to 1 milliampere when VC is how much? 1 volt. If this VC is increases to 11 volts, then what is the collector current? Right? What is the formula? That is IC2 equal to IC1 into 1 plus delta VC by VA. Right? What is IC1 here? 1 milliampere, 1 plus, this is 11 minus 1 by 75, which is equal to how much? 1.13 milliamperes here. This much current will be increased. Copy. Yeah, copied. And the next one, calculation of output resistance. Second one, calculation of output resistance. That is R0. Second one, calculation of output resistance R0. Right. Now all of you see here. See, what is an output resistance actually? You know, output resistance is nothing but it is the reciprocal. It is the reciprocal of slope of output characteristics. Output characteristics of a common emitter configuration. Right? See here, what is the slope for this curve actually? The slope is nothing but what is the slope actually? That is dou IC by slope. Dou IC by dou VC. Right? So dy by dx simply. Dou IC by dou VC. Right? Now see all of you. Right? Now see all of you here. I am calculating the slope actually. Here, for calculating of slope actually, here I am considering only 2 points. Consider A and B points. A and B points. Right? What is the slope actually? The slope is nothing but IC1 minus 0 by VC1 plus VA. Right? Right? Now tell me what about it is IC by VC plus VA. This is the slope. Right? Now see all of you. Now what is R0 here actually? R0 is nothing but slope of output characteristics of configuration. What is the slope here actually? That is IC by VC plus VA. Okay. See, this can be written as R0 equal to VC plus VA by IC. But this VC is very small compared to VA. Early voltage in order of 50 volts to 100 volts, right? Then what is the output resistance? Output resistance is nothing but VA by IC. this is an output resistance, right? See here, if early voltage is negligible, if early effect is negligible, if early effect is negligible means the early voltage is tends to 0, then what should be the output resistance? Actually the output resistance is 0. Copy. So in this way we can calculate the collector current when VC changed and also output resistance with help of early voltage, right? Yeah, copy this one.